I think we are live now.
Yes, sir. Virendra sir, we are live.
Thank you, sir. So welcome back again in today's session, today's live session. Today we have Dr. Shashi Kant with us. He will be speaking on some application of mathematics in different field, especially meteorology or weather forecasting. So Dr. Sasikant completed his PhD from Delhi Technological University, and also he did MPhil from Agra University. He joined India Meteorology Department in Ministry of Earth Sciences as scientist after the selection through UPSC in 2015, and currently serving as a scientist in the same department. Dr. Sashikant has published more than 20 research papers in International Journal of Repute, and he is currently working on operational meteorology and allied area. In addition to this, his research interest includes mathematical modeling applicable to different fields of physical sciences. Dr. Sashikant also has given many invited talks at different platforms. So today we have Dr. Sashikant. He will be speaking on application of mathematics. We are welcoming you, sir. So, and we are really feeling honored to invite you here. So, I would like to request you please deliver your talk. And thank you, sir. Please. Hello, sir.
Yes, yes.
Are you able to hear me?
Yes, yes.
Okay. Thank you, sir. Please.
So, is it visible? Slides are visible?
Yes, sir.
So, thank you. I am very much glad to hear that Virendra sir is also my senior also in my PhD times, because I joined PhD after his admission. So, he is my senior in DTU, and I am very much thankful to him to call me and give an opportunity to speak about my experience in my department of weather forecasting. So today I will discuss some of the areas where mathematics have potential application in this meteorology and allied sciences. So the main purpose is to understand that mathematics is also one of the basic and applied sciences which have an potential to applied in different areas. So accordingly, the theme of the today's talk is application of mathematics in weather forecasting and allied areas. So this is I have set some roadmap through which I will pass. That is, what is weather forecasting, its importance, and what is it, and the process of weather forecasting in terms of mathematical issues, challenges in weather forecasting, why forecasting goes wrong, limitations I will discuss, and the basics of numerical weather prediction models. And I will also discuss about some of the potential areas of research where we can engage ourselves to do something in terms of mathematics and application of mathematics in some of the areas. I will give one or two examples, and if in between if you have any question you can go through, no problem. So why we need weather forecasting? We all know that weather forecasting is very much important for any planning and any issue that you can have in future also. For example, in case of if there is a forecast for heavy rainfall and you are going for Manali and you see that there is a heavy rainfall forecast for Manali, then you will skip those periods. So accordingly, there are a lot of extreme weather events like heavy rainfall, flood, and cyclones, because these events have potential to damage not only human resource but also economically. So the weather forecasting accuracy and in time of such extreme weather events is very much essential, and it is related to all, not only this big man, it is also related to the common man. So it is related with all. Weather forecasting enables farmers to adjust their farming activities. For example, during next 15 days, if there is no expectation of rainfall, then the farmer will set accordingly our crop plan. So this is the application of weather forecasting in agriculture related activities, or farmer will arrange some alternative for irrigation. Similarly, uh, not only this about farming and other activities, it also affect all types of the transport. Either it is in the ocean, or in transport in aviation, or in surface transport. Because if aircraft takeoff and landing can be affected by weather. For example, if there is a strong wind or there is a thunderstorm, then this will delay this about aircraft takeoff. So for aviation and shipping also, this weather forecasting is very much essential. And weather forecasting can help us to guide and encourage tourists to visit certain areas. For example, if it is predicted that certain areas will be warm in future, then tourists from cold areas will travel to this area to enjoy the forecasted warmth. Similarly, if there is a forecast for this snowfall in Srinagar or any other area, then tourists from hot places will move to that place to see the snowfall. So this is the importance, some of the importance we have highlighted, and it is also essential for scientific studies and even military operations. So this is very much important. So accordingly, in India, this India Meteorological Department is responsible for government agency. It is a government agency, and it is responsible for all types of weather forecasting in India. So I am belonging to IMD. So now we come to the process of weather forecasting. Is it really a mathematical problem, or it is other one? So actually it is a mathematical problem, because this is nothing but it is a forecasting of predict the conditions of atmosphere by application of some tools and techniques, especially mathematical techniques, for a given location and time. So this is nothing but it is a science, and now question arises what to predict. So the purpose is to predict the atmosphere. And what is atmosphere? We all know atmosphere is governed by different issues. For example, if we want to predict the atmospheric conditions, so then in that case we have to predict some particular values of different scenarios. Like for example, rainfall. So rainfall is nothing but it is a precipitation of water or snow. So it is a forecast of rainfall. So in that way we have to consider the observation of different parameters, atmospheric parameters. For example, here we have listed 4 parameters, that is pressure, temperature, water vapor, that is moisture, and wind. So these are the 4 important parameters we have to observe. So pressure, temperature, and water vapor, these 3 variables are scalar quantities. However, wind has this direction and magnitude both. So wind is a vector quantity. It will follow or govern all the physical quantities, that vector rules and regulations of mathematics. So vector calculus is applicable to wind. Accordingly, these all properties are continuous in space and time. That is, if they are the function of x and t, then they will be the continuous function of in x and t. In that way, these are the called the field variables. So whole the atmospheric science or meteorology is based on these 4 parameters, that is pressure, temperature, water vapor, and wind. So if we know that we have to observe these four parameters, then how many steps we have to follow, so that in systematic way we can observe this weather forecasting process. So first step is the observation and analysis, and second one is application of the mathematical tool, and finally the prediction of particular variable. So these are the 3 steps through which we can complete our weather forecasting. So observation is again a systematic, because observations are of different kinds. For example, in case of surface observation, in India we have 2 types of observatories. That is, one is manual surface observatories, and other one is recent progress automatic weather stations, that is AWS. So automatic weather stations, recently in last decade we have implemented and this installed different locations AWS. However, manual surface observatories are very much old. not only after 1947, but also pre-independence manual surface observatories was installed by this English government also. And second is upper air observations. Upper air observations, in that way we have radio sonde, radio wind and pilot balloons, and we have observation through satellite and radars and aircraft observations. And in sea we have again sea point view and satellite and radars. So these are the three types of observations, that is surface, upper air and sea. And it is not also that any time you can observe, there are a standard time when we have to observe. So internationally we have a standard time, that is universal time coordinated UTC. We have four important observation time, that is 0, 6, 12 and 18. If we convert UTC to this Indian time, then we have to add 0530 hours, that is 5.5 hours I have to add. So in India, this main synoptic hours, that is main observation hours, are 3 and 12 UTC. 3 UTC means in morning 8:30, and 12 UTC means 0530 hours IST in the evening. So these are the three, these are two are the main synoptic hours when we have to observe the weather parameters. And for upper airs again, we have international times, that is 0, 6, 12 and 18 UTC. But in our case it is 0 and 12 UTC, that is in morning 0530 hours IST and in the evening 0530 hours IST. And for pilot balloon also we have four standard time, 0, 6, 12 and 18 UTC. So this is the pattern of, actually we have different types of charts in our computers nowadays. So through surface charts and other charts we monitor that where is a cyclonic circulation, where is a convergence, where is a divergence. In that way we this analyze our weather charts, and then we conclude the weather conditions. And we have a mathematical problem. So weather forecasting is a initial value problem if we look at it at global scale. So if we model this equation simply, delta f by delta t equal to function of f, that is f means field variables, but we have five field variables. So this is the situation. So we look at this function of small f, function of time of function of f, that is if any particular of time, suppose tf, we observe a small f, then we have to consider initial value of this f and then capital F into delta t. So this is a simple initial value problem. We can have initial value conditions and we can solve. But it is looking very simple. It is not so simple because this our atmosphere is non-linear in nature. So our mathematical formulation is non-linear differential equations, and we all know that the solution of non-linear differential equation is somehow is not, analytic solution is not available. In that way we approximate by approximating some of the initial conditions. So it is a approximation problem only. However, in that way, simple way we can see that weather forecasting is an initial value problem. If we look at, if we restrict our forecasting for a particular city or a particular area, in that way then we have boundary condition also, because in that way we will impose some boundary condition. In that case this mathematical formulation will be initial boundary value problem. So therefore we can see that weather forecasting is also a boundary value problem. However, in generally we have initial value problem. So now move to basics of numerical weather prediction model. Numerical weather prediction is nothing but an application of this mathematical tools and techniques for weather forecasting in this systematic way. So that is called the numerical weather prediction. So numerical weather prediction actually a very old techniques. However, nowadays it is a very developed and very developed science in area of weather forecasting, and we have systematic different mathematical and numerical weather prediction models. India also running our global forecasting model. So we are independent in that way. So numerical weather prediction is a method of weather forecasting that employs a set of hydrodynamical equations that describe the motion in the atmosphere and oceans to predict the future weather condition based on current weather conditions. So what are these current weather conditions? These will serve as a initial value conditions for this our mathematical issue. And current weather observations serve as input, that is initial condition, to the NWP models through a process known as data assimilation to produce weather forecast of temperature, wind, precipitation and other meteorological parameters. So therefore, NWP is nothing but it is a process of solving of hydrodynamical equations by inserting some of the initial condition through the process of data assimilation, and then we will in a stage to forecast our future condition of the atmosphere. So we will quick through history. History in that way we can say that in Richardson in very earlier stage, that in 1922, by his book Numerical Process, published by him in 1922, they tried that they can predict weather numerically, and Richardson showed how the differential equation governing atmospheric motion could be written approximately as a set of algebraic differential equations for values of tendencies of various field variables, that is those five variables, at a finite number of points in space. So they tried initially, first of all, they initially tried that this weather forecasting can be done by numerically. So he was thinking that they can transform these differential equations in terms of algebraic differential equations, and the observed values of these field variables at these grid points of the tendencies could be calculated numerically by solving the algebraic differential equations. Actually, he tried to, to bifurcate our this globe in terms of different grids of equal size. For example, 2 by 2. So 2 kilometer by 2 kilometer means 4 kilometer grid. So this was the initial attempts, and we will quick through that. After that, Richardson did not foresee the development of high speed computers. They failed because at that time that this digital computers or high speed computers was not there. So they think that his problem could be solved by the workforce of 64,000 people, simplify to keep up with weather on a global basis. So that was the estimate that if he try to solve this problem, then he will require 64,000 people. Then he could solve this weather problem on global basis. So that was very difficult. And Richardson tries forecast by hand. Unfortunately, the results were poor because of poor initial data and the inclusion of fast waves like sound and gravity waves. Numerical weather prediction was not attempted again until World War II. So after Richardson, this progress of this NWP stopped, and till World War II could not progress. Interest grew due to the improved meteorological observation network and the development of digital computers. After that, so in Charney in 1948, how the dynamical equation could be simplified using the geostrophic and hydrostatic approximation, so that the sound and gravity waves were filtered out essentially due to the quasi-geostrophic. These are some technical terms used in weather forecasting area. A special case of his model, the equivalent barotropic model, was used in 1950 to make the first numerical forecast. So 1950, we have this first numerical forecast. We are escaping it because it is a history only. So now we come to the primitive equations. Primitive equations in NWP case, we have actually three rules. First is conservation of mass. Second one is conservation of momentum, that is form of Navier-Stokes equation in fluid dynamics, and thermal energy equation relating overall temperature of system to heat sources and sinks. So these are the three rules. Based on these three rules, this Journal of Applied Math 1968, six layer primitive equations. In fact, there are seven equations. So these are the equations that is called the primitive equations. So first equation is nothing but it is in this is governing for u, small u. So if we consider vector wind vector b, that it is horizontal component is u and u and b, and this vertical component is g, then in that case this equation first and second are the governing equation for the wind. So accordingly, this theta is nothing but it is a potential temperature, and if small p is the pressure and capital P is the standard pressure, that is 1000 millibar. So these are the set of equations which is foundation for the numerical weather prediction models. So this source is given. Anybody interested in detail can download this paper, freely available PDF, and they can look at how beautifully this weather forecasting problem in terms of primitive equations has been done in terms of this mathematics, and they have discussed various previous attempts, and then in this USA Department of Math they have solved this issue and they are using. So these are some symbols in that equations I already told. So this is the set of 7 equations. So if we look at this is actually general equation. If we put sigma equal to z, sigma equal to g or z, then we will completely have Cartesian form. And if we put up sigma equal to p, that is pressure, then we will look at isobaric. And if sigma equal to t, then theta, then asymptotic. And if sigma dot, that is this velocity equal to 0, then quasi-Lagrangian system 1945. And if sigma equal to p by p star, then it is 1956. So this is a general model. You can solve any three by putting different values of sigma. So this is we have adopted from lecture notes of SK Das IIT Delhi. So this is the again the same in simplified version, that horizontal momentum equation, that is dv by dt plus fk cross b minus del phi plus sigma by ps del phi by del so del ps plus f. So this is the horizontal momentum equation. And our in mathematics fellow in fluid dynamics are very much aware about the continuity equation. So this is the continuity equation, second equation. And third one is the thermodynamic energy equation. So this is the accordingly this is the hydrostatic equation, and this is the surface pressure tendency equation, and this is the moisture equation. So these are the 6 equations. We can have any NWP general model. Otherwise in different module of NWP, because if we put up inside the ocean state, then it will be the atmospheric ocean coupling. If we look at land use or land cover, then we can also assimilate a different scenario of clouds, etc. So but these are the 6 basic equations through which NWP is based, and all are the heavily dependent on these 6 equations. These are nothing but about the symbols. So this is the example of this our NWP product. So after solving these 6 or 7 equations numerically by using supercomputing or high performance computing, we for Indian, this is the map from the global forecasting system model running at our Indian system, Indian IMD. So we can see that with a different legend, actually this is for valid of this 6 UTC of 8, that is 11:30 of today. So from this different legend, we can say that this dark blue color shows that this 70 to 130 rainfall in during 24 hours is expected over this west coast. So this is an example how after solving this mathematical equations on Indian map, we can so have this rainfall estimation, that expected rainfall. So this model is available for next 10 days based on this 0 UTC of this today, and model is available on our website for next 10 days. So this is some idea about that where is expected of rainfall during next 5 to 10 days. And so this is the look at, this is the picture generated through supercomputing after processing this NWP models. Even though after development of these digital computers and high performance computing, still we have suffering with some of the limitations. For example, in computational issue, sometimes some of the countries is suffering with the computational issue, because even though we have supercomputers, but these equations are nonlinear in nature, so we require more and more computational power. And similarly, if our observation is that is this initial conditions are erroneous, then this forecasting will be wrong. And again in errors in approximation and estimates, because sometimes our grades this observabilities are not uniformly distributed. So we have to estimate for the missing data either in interpolation manner or extrapolation manner. In that approximation sometimes there may be error. So because of this error, this forecast may be erroneous. Again, computational errors may also be because we are dealing with a different set of equations, but sometimes we are not aware about the predictors, or it may be changed from location to location. So that in that way this weather forecasting may be wrong. Sometimes data may not be available because of different reasons. Sometimes this data itself is lost. We have data, but because of some different noise or this during the sending this message is erroneous, then this will lead to the forecasting will be wrong. So these are the some issues we are suffering with. However, weather forecasting in last 10 15 years has significantly improved, and you can also observe that this weather forecasting is somehow uh, very much accurate. So these are the some example where we can apply our mathematics, that is different areas where we can apply our mathematics and mathematical methods to publish different good research paper also. Here one is the rainfall analysis. We have listed here source. You can go through this source and you can read this paper, and you will understand how we can do rainfall analysis. For example, each and every statistical distribution, that is log normal, in their paper we have found that log normal and gamma distribution are suitable for this annual and monsoon season period of study, and generalized extreme value distribution is suitable for weekly period, and this for monthly data, and this for different month to month different probability distributions are required. So from this paper we can see that for different time scale of rainfall analysis we can use different this probability distributions. So my summation and recommendation is that you should go through the rainfall data, and you can analyze for our area, our city or our state, that what is happening. You can go through long period data also, and you can sum up that is there any significant change in rainfall distribution, or any change in rainfall pattern due to the climate change, or there is no change, or what is change. So you can go through different, and data is available on our this department. You can write to us, that you can inquire us that where is the data of my state or where my city. You can go through the study of rainfall analysis. So it is recommended to go through this paper and understand how we can select this suitable probability distribution for different scale, time scale, and different area wise. So this is again water balance equation. We are putting here water balance equation. For example, suppose precipitation or rainfall is going on, and some dam, for example in Hirakud dam is continuously filling up. So dam manager, what he will do, because if there is a forecast for next 10 days that there is a possibility of heavy rainfall, then this dam manager should be aware about that. If continuously is rainfall, then this dam will be full, and overflow will lead to the severe flooding of that area. So in that way, this dam manager should understand and should decide that should I open the gate right now, or how many gates should be open. So in systematic, this water balance equation is also very much important, because from not only for dam area, but also for this particular basin or particular area, you can think about the flooding or this runoff, that after this so and so rainfall this runoff will happen or not. Because if soil is sufficiently saturated and if rainfall is continuing, then definitely this earth will not surface will not consume but much water, so simply it will run off. So runoff is nothing but it is a overflow of the water. So this is the P minus R minus G minus E equal to ds. This is the general water balance equation in a one form. So P is, what is P? P is a precipitation, and R is runoff. Runoff means R out minus R in. R out means from this outflow from the water body, and R in is this influx into the water body. Water is coming to the water body, and water is going from the water body. So this is the runoff. Runoff is R equal to R out minus R in, and G is the groundwater flow. So groundwater flow is what? G equal to G out and G in. That is, G out means groundwater as outflow from the water body, hydrologic region, and G in groundwater as influx into the water body. So E is the evaporation and T is the transpiration. Some of the research papers this combine ET, that is evapotranspiration. One term is there, evapotranspiration. And DS is the change in storage. Change in storage, if it is a case of dam, then change in storage is leading by ds equal to P minus R minus G minus E minus T. That is, after precipitation, water will go where and where. In other words, we can also simply written as that this again water balance equation: precipitation equal to runoff plus infiltration plus evapotranspiration plus change in storage. So we can also write it as P equal to R plus ET plus delta S. So P is the precipitation, R is the stream flow, and it is the evapotranspiration, and delta S is change in storage. So you can also read this water balance equation. We have here given link. You can click on this link and you can read about the water balance equation also. So one of the important area is the cyclone. Tropical cyclone is very much important because it is a devastating system. Usually our this Indian Ocean, North Indian Ocean experiences 4 to 5 cyclones in a season before the monsoon period and after the monsoon period. And most of the time these cyclones proved they are very devastating. So understanding of tropical cyclones is also important. And in that area, these mathematical equations and so models are very much important. So here we have listed out one of the model. Again, these are the 6 equations, and you can click this link where from you can understand the dynamics of cyclones, how mathematics is applicable, and there are a lot of research paper in this mathematical study of tropical cyclones, and you can also go through a statistical studies of the cyclones, and all are the details and all are the details of the previous cyclones are available on our this Mosam website, that is mosam.imd.gov.in. You can visit our website and you can work on this cyclone area also. So this is the all about different areas, how mathematics can applicable in different areas, because in dam management you have to require this different equations. In farming categories, when we have to crop, when we have not to crop, when we have to harvest, when we have not to harvest, and these are very much important. So you can forecast for this in that way also. For further reading, you can visit our this mosam.imd.gov.in, and we have for this model chart of NWP, you can visit our this imd.gov.in NWP website, and you can visit our for NWP detailed lecture notes, and this link is there, and our previous studies in terms of math monographs also available on our IMD. And one of the popular book in this mathematical methodology, that is dynamics on dynamic methodology, written by J.R. Halton, is very much popular book. You can read it, and it is a very good book. And IMD is also publishing one journal, that is Mosam Journal. It is SCIE and Scopus Index. It is an impact factor, and it is one of the oldest journal. And all the research papers past 50 to 60 years are available on this our mosamjournal.imd.gov.in. You can submit a different research paper on this journal also. This is a very good journal, and it is SCIE and UGC listed and Scopus also. So we are publishing one journal. You can submit your research paper in this journal also. So this is the all about. Now you can put up any question, any query. Virendra sir.
Yeah, sir. Thank you so much, sir. The chat box of our YouTube channel. On YouTube, we have so many comments in appreciation, and they really liked the lecture. Actually, the forecasting and all these are very much relatable, and many don't know how the forecasting is done and how mathematics is useful, particularly in this area.
Yes.
So I would like to ask Dr. Sumit if there is any question from participant side.
Thank you, Dr. Virender. As told by you, I can see that in the chat box of YouTube, all are fascinated by the fact that mathematics is used in weather forecasting a lot. And it was a opportunity for them to listen to you, sir. And they got the lot of information from this session. And although there is no such question, they are only appreciating the lecture.
Actually, this is very new to the mathematical audience, because usually when we speak in among this particular area, then lot of questions, because some of the technical terms they are not aware about. For example, geostrophic, what is geostrophic, they are not aware. But in fact, this equation, this mail I have shown again and again. If any this in future also, any guidance or any feedback, any comment or any inquiry about this, they can mail us. This online skmisra@gmail.com. I will be happy to respond in any manner, in scientific, in any career also, that where they have to apply, how they prepare, and how they publish, how to publish research paper, I can help them. And as I already told, they can submit their research paper in our Mosam journal. This is CIE and this is Scopus and have impact factor also. So this is a very good journal, and all the research papers of past 50 years are freely available, downloadable. They can select their research area. Suppose they are interested in the rainfall analysis, they can accordingly download the papers, and they can start from the zero level. They can start right now. So within 6 or 7 months they can mature and they can write the research papers after some of the terminology. So it is a very good opportunity to mathematics faculty, young research scholars, or they have just completed PhD for publication. It is my recommendation and submission that they can go through our this research papers fully available on our Mosam journal, and they can start and they can write mails. If there is no any specific question, then no issue. But this is the overall. So thank you. And if you have any query, you can, sir, ask Sumit, sir. No problem, sir.
Sir, there is one query from the participant. Hydrodynamical equations are specific to rain.
No, they yes, actually, rain is a byproduct. Before rain, there is a cloud formation. So how to cloud form? So prerequisite for cloud formation is first is the moisture, and second is the temperature or instability in the atmosphere. So if moisture is there, so there is a moisture equation. In this sixth one is the moisture equation. So moisture is the leading factor for cloud formation. And if there is a cloud, then every cloud is not going to give rain. So which cloud will give rain? This will lead by other factors. For example, if there is a temperature, is a high temperature, and there is a cloud formation, and if sudden sufficient moisture is available, then thunderstorm or lightning will be there. In also pre-monsoon also. In May or June, you will see that sudden cloud formation, thunderstorm and lightning, rain, and then sky is clear. Contrary to the monsoon season. During monsoon, we have a full day cloudiness, but rain is in intervals. But in monsoon season, sudden cloud formation, then due to the temperature or other factors, this lightning and thunderstorm and rain, and then within 1 or 2 hours, clear sky is clear. So that way, this moisture equation is important. How moisture is going to change within the time. So suppose this is a 40% moisture is right now, and after 2 hours or 3 hours, what will the amount of the moisture? So this will lead to the this. So there is a moisture equation. So that is the that will give the cloud formation, and accordingly, rain will be there.
Okay, sir. Sir, there is one more question.
Yes.
Which software could be used to solve the PDs which are mentioned in the presentation?
Actually, there are different tools and techniques. For example, we have systematic differential equations. Now, with the some initial condition, we have to solve. So there is a standard method. Actually, these are being solved by some supercomputer. We have IMD and this Ministry of Science have a supercomputing, and this finite element method or finite volume method. There is a grid scale analysis also there. So they are using that way. But in limited scale, we can use either finite element method or finite volume method on our laptop also for a small region, a small equation. So we have shown actually WRF, that is a global model. But IIT Delhi or some institute solving this regional model also. That model is called WRF. Regional model is a low scale model that is for a particular small location. For Delhi, they are running suppose WRF. WRF weather research forecasting. WRF means weather research forecasting. So for a small area, we can anybody can solve. These are the non-linear partial differential equations with some set of initial conditions, and they are capable to create some new codes in other language also. They can solve. They can try to solve. So there is no specific or unique method that they are solving. We have to solve. You can create itself your own codes. They can solve in MATLAB also, but because these are very huge initial conditions, so sometimes it's our in-house laptop or they cannot solve. So that's the way we have to require some this supercomputing. Otherwise, small equation can be solved by any method.
Okay, sir. So there is one more question. How big is your data which has to be processed during the?
It is a very huge data, because in global forecasting model, actually in Delhi we have this is called regional telecommunication hub. So in India, in Delhi headquarters, we are receiving data from most of the countries. We have some convention is there, but that is called World Meteorological Organization. It is a very international organization through which we are getting data from each country, including Pakistan, Afghanistan, Bangladesh, China, and this USA, UK, Japan, everywhere. From everywhere we are having real-time data. On this 8:30 morning, we have data from all over the globe, and this data is going to this NWP model as an initial condition. So this is a very huge in TBs number of very huge data. So in that way, we have to require supercomputing. And on daily basis we are this running GFS two or twice or thrice a day. That's why we have shown an image how this difficult, but we are managing because India has supercomputing, and we are not second to other countries. In case of cyclone forecasting, India is not second to others. We have good cyclone forecasting with high quality and high accuracy. In recent past, we have forecasted so and so cyclones very beautifully. So in that way, this is a very high and very huge data.
Yes, sir. Sir, there is one last question. How to identify or forecast the severity of rainfall? Is there any mathematical modeling attributed to it?
Yes, extreme weather events. I already told that this for suppose this rainfall more than 20 centimeter. So we have to segregate. There are probability distributions also. And this probability distribution deal with only the data more than 20 centimeter. And this distribution will deal with this less rainfall data. So this is again a subjective matter, because I have seen so now this for yearly data you have to apply that log normal and this Gumbel distribution, and for this weekly analysis there is a requirement of different distribution. So this that paper is very important through which you will understand that which distribution is applicable for what data. So this is the shape of the data may change time to time and location to location also.
Okay, sir. Sir, thank you very much for such an enlightening session. Over to you, Dr. Virender.
Thank you, Dr. Sumit. Sir, I have one general question. So,
Yes, sir. Yes, sir.
the question is that we see the weather forecasting from different websites like AccuWeather and all. Yes, so yes, how they get the data, accurate data? In fact, AccuWeather is supposed to be very accurate in weather forecasting. So the government used to send the data or forecast kind of thing, or they themselves generate the data for the world.
Actually, we have a good network of radar and the satellites, and also some of the international agencies like European Center of this Meteorology, that is ECMW we are calling. So different sources are there. Now people are but because data is this available freely. Our radar data is available on our mosam.imd.gov.in. Satellite is also available mosam.imd. So sometimes they ask me and they permission required from this our department and different department also. Sometimes they don't, because there is they can apply this algorithm and they can push up our data without knowing me. So but our different apps, for example rain alarm is there. If you download rain alarm, so then rain alarm our data is going on. But in this some of the web, just what you mentioned AccuWeather or etc., in Google also, in our mobile also, you can download different weather app or and so they may ask to us or may not be, because data is freely available. We have not any charging or any rupees demanding from our Indian government side, so we can not stop, because this is the public domain data. You can also use, you can create your app and you can link with our this direct radar data, you can forecast. So that is the problem. But most of the times we are aware about that data is ours. Sometimes may not be.
Sir, one more thing. In India, this is a rain forecast system and all. We see that they are not much accurate than other countries. Like I have been in South Korea, so I have seen there. So they have the data and very accurate data for every hour and every minute. But if I see that in Delhi, suppose I'm living, and then I see that there is chance of 14% of rain today, but it may be heavy rain on that day. So why this happens?
This is there are two, or because that's why we have put this why forecasting goes wrong. We have dedicated one slide here also. in in our case, or in any tropical countries or subtropical countries, this weather is changing very sudden way. In that case may not be in Korea or in USA, where this climate or weather is not changing so instantaneously as compared to our tropical and subtropical countries. In India, this weather is very changing. In each second weather is changing. So that's why this first problem is that this weather is quite random in nature and changing in instantaneous manner. Secondly, this rain forecast is in that case may not be accurate, because suppose be IMD forecast that there will be a heavy rain in Delhi. So we have limited observatories. Suppose in Rohini there is a heavy rainfall, but in the South Delhi this IIT may not experience any rainfall. So if anybody see in media that there is a forecast for heavy rainfall in Delhi, in resident from Rohini will experience the rainfall, then they will call the yes, rainfall is correct. But in the IIT Delhi, because in recent past, in 15 or 16 days ago also, this our ridge area experienced very heavy rainfall, but in Mehrauli, South Delhi, we experience very less rainfall. So this rainfall pattern may also change, because in our case grid is only Delhi, for example, 25 by 25 kilometer is a grid. So our grid is a very this large in scale. So in that way, this forecast experience is wrong. That this forecast is because we are not going to location specific, and others be observatory also not uniformly distributed, because in that way we have to require a observatory in each case. Rainfall is there, but our observatory is not observing in that way also. And but you have said that forecast is not so accurate. It is yes, 60 to 70% accurate, 30% is may not be accurate. That is correct.
Okay, sir. Thank you very much, sir. Uh, there are so many questions that are coming in the chat box again. So, is there any role of fuzzy logic in weather forecasting?
Yeah, there are recently I have seen some of the research papers where they are using fuzzy logic also. So yeah, one can try with our this data, rainfall data and temperature data. They can prepare a mathematical modeling using fuzzy logic also. So yes, fuzzy logic can be applicable. Neural network, etc., machine learning, artificial intelligence. These are using in our this even in this stochastic process. This is Monte Carlo simulation, and our this stochastic process is a potential application. This in our weather forecasting. Research papers are there. One can go through the literature, no problem.
Okay, sir. Sir, one more question is there. Is there any relationship between this model and Navier-Stokes equation? I don't know which model he is talking about.
Yes, this NWP is a,
Navier-Stokes
yes,
Navier-Stokes equation. Yeah.
yes, NWP actually itself using this and Navier-Stokes equation. I have mentioned here.
And
Conservation of mass and conservation of momentum, somehow they are some kind of Navier-Stokes only. We have approximate Navier-Stokes only. These are the fluid equations actually, fluid dynamics equations only. That's why we are calling hydrodynamical equations.
so, one can we apply graph theory in weather forecasting?
Yes,
I don't know
graph
how much
theory and
relevant.
yes, graph theory and network theory also, because we have the network of the observatories. Suppose in Delhi we have 49 rainfall and rain gauge stations of rainfall measuring stations, and we are you will see that data of each observatory is not uniform. Some observatory will see 24 hours data is 5 mm, some will say 6 mm. So you will decide that this observatory should be shifted from year to year. If node is correct, node is not correct, yeah, based on this initial condition weather forecasting is going wrong. So you can accordingly using apply network theory, you can suggest that yes, this network should be here, or this should be here, or this should be in between in these two. So yes, network theory has potential application in weather forecasting also. Graph theory, network theory, both have application.
Thank you so much, sir. We got answered so many questions. In fact, this was a very interesting question answer session after the talk. And really, we are very much thankful to you, sir. You accepted our invitation and enlighten us with this information. In fact, it is very hard to get the application. In fact, in weather forecasting, as earlier, so many people. In fact, I was also not thinking that this may be useful, because I have seen when I was in Korea. So I seen that there are different departments, not in mathematics, but they were doing in the physics department,
Yes, yes.
the study and all. So they were, in fact, they were hiring some computer scientists and on for coding, etc. So there were hardly mathematician working, but now I am saying that really this is fascinating to see that how mathematics is very much useful in it. So thank you so much, sir. I have seen that your publication and all. In fact, I would like to recommend, if anyone want more information in this direction, they can contact you on this email. And thank you so much, sir. Thank you for coming.
So,
And
so be
thanks
kind
to
up. Okay,
participant
sir.
you also.
Thank you.
Thank you, sir.